Find the sum to n terms of the following Arithmetico-Geometric series. Okay, let us begin. So here we have a Arithmetico-Geometric series whose first term is 3. This is added to the second term, which is 5x, followed by 7x squared, added to 9x cubed. Our goal will be to find out the sum up to the nth term, and for this we will be needing the nth term of the series. Now let's try to figure out what's the nth term of the given series. Now since it's an Arithmetico-Geometric series, it's clear that the series is composed of a arithmetic progression and a geometric progression. Now to find out the arithmetic progression, we'll start with the constant term. So here we have 3, followed by the constant term 5, then we have 7 and 9. So these terms are in arithmetic progression. If they are in arithmetic progression, then we can easily define its first term and its common difference. That means the first term is going to be 3 and the common difference denoted by d in lowercase, so that's going to be 2. Now what's the nth term of the given sequence? The nth term is going to be defined by a plus n minus 1 times the common difference d. So that means we now have 3 added to, we have n minus 1 times d. What is d? d here is 2. So this is going to give us 3 plus 2n minus 2. That will be equals to 2n plus 1. So this is going to be the nth term of the arithmetic progression. Next, to find out the geometric progression, what we'll do, we'll take 1 from the first term. Then from the second term we have 5x, we're going to consider the variable x. From the third term, we're going to consider x squared, then x cubed, and this continues. So these terms are in geometric progression. If they are in geometric progression, then the first term, that's going to be equals to 1, and the common difference d, that's going to be equals to x, which means that the nth term of the geometric sequence, which is defined by the formula a raised to the power of n minus 1. So substituting these values, we're going to get x raised to the power of n minus 1. So now we have the nth term of the arithmetic progression and the nth term of the geometric progression. This is going to help us obtain the nth term of the Arithmetico-Geometric series. So an equals to, we're going to consider the nth term of the arithmetic progression, which is 2n plus 1, and to it we are going to multiply the nth term of the geometric progression, which is x raised to the power of n minus 1. So this is going to give us the nth term of the Arithmetico-Geometric series. Now we can represent the sum as, let Sn. This is going to be the sum that is going to represent 3 plus 5x plus 7x squared plus 9x cubed all the way up to the nth term. So the nth term, that's given by 2n plus 1 multiplied to x raised to the power of n minus 1. We're also going to consider the second last term. Now the second last term is, that's a simple task. All you have to do is replace n. We're going to replace the n value with n minus 1. That means when we substitute n with n minus 1 in 2n plus 1, so that's going to give us 2n minus 1. And this will get multiplied to x raised to the power of, so we have the last term is n minus 1. If we substituted n with n minus 1, then we have x raised to the power of n minus 1. Fine. Now, what we'll do, we're going to multiply each terms on the right hand side with the common ratio of the geometric series. The common ratio of the geometric series is x. So that means what we'll do, we'll multiply throughout with x. That gives us x Sn on the left hand side, and on the right hand side we have 3 multiplied to x. So that will be 3x. Added to 5 multiplied to x will give us 5x squared. 7x squared multiplied to x will give us 7x cubed. This goes all the way up to the last term. So here we have 2n minus 1 times x raised to the power of n minus 2. When multiplied with x, we get 2n minus 1 multiplied to x raised to the power of n minus 1. And the last term is will be 2n plus 1 multiplied to x raised to the power of n. Okay, now what we'll do, we're going to subtract the Sn from x Sn. So we get x Sn minus x times Sn. So what we'll do, we'll have here the first term 3, and then we have the last term, which is 2n plus 1 times x raised to the power of n. We are going to subtract it. Now what we'll do, we'll take the terms from the second term till the last term, nth term, and subtract the corresponding terms from xsn. So 5x minus 3x, that's going to give us positive 2x. That will get added to. So 7x squared minus 5x squared, that will be 2x squared. Added to 9x cubed minus 7x cubed, so that will be 2x cubed. So this is going to continue the term 2n plus 1 times x raised to the power of n minus 1 minus 2n minus 1 times x raised to the power of n minus 1. 2x raised to the power of n minus 1, and then we have the last term. Okay, now on the left hand side we can take Sn as the common factor. So Sn will get multiplied to 1 minus x. This will be equals to, we'll keep the first term as it is. Now what we'll do, we're going to add up the second term all the way up to the second last term. Now this is a geometric progression. Now in this geometric progression, we know there's a standard formula for obtaining the sum up to n terms. So we have the first term, which is 2x in our case. This will get multiplied to 1 minus the common ratio. The common ratio, that's x. X will be raised to the power of the number of terms. So divided by 1 minus the common ratio x. How do we know that there are n minus 1 terms? So here we have n number of terms in total for Sn. Now, if we do not consider the first term 3, then starting from the second term to the last term, so there will be in total of n minus 1 terms. So that means from 5x all the way up to 2n plus 1 times x raised to the power of n minus 1. So there are a total of n minus 1 terms present here. Similarly, for xsn, here 3x is the first term and 2n plus 1 multiplied to x raised to the power of 1, that's the last term. What we'll do, we'll consider the first term all the way up to the second last term. So this is also going to have n minus 1 number of terms. Okay, so here if we subtract Sn from xsn, so this particular portion is only going to leave us with n minus 1 terms, right? Because here we have not included 3 and we are not including 2n plus 1 times x raised to the power of n, the last term of xsn, when we were subtracting. So that's why this particular geometric series has got n minus 1 terms. Okay, and we have the remaining term, which is 2n plus 1 times x raised to the power of n. Okay, almost done. Now what we'll do, we're going to divide both sides with 1 minus x. So that gives us Sn equals to, we have 3 divided by 1 minus x. Added to, so we have 2x multiplied to 1 minus x raised to the power of n minus 1 whole divided by 1 minus x whole square, minus we have 2n plus 1 divided by 1 minus x. So this entire expression will get multiplied with x raised to the power of n. So this is going to be the sum to n terms of the arithmetico-geometric series.